experiments 3 and 4, officially 2 experiments, but very straightforward, okay, and effectively the same experiment. So one experiment has a little wire, and where all we're doing is finding out the effect of temperature on the resistance of the wire. Okay, simple as that. And then we have a thermistor, which is a temperature dependent resistor, and we're doing the same. Okay, gives you different results. We're going to do the 2 of them together, okay, because they're pretty much the same experiment. Okay, so first of all, okay, so this is our apparatus that we're going to use for our coil. So that's a coil of wire. Okay, it's in this for protection, so that just goes in like that. Okay, and we're going to connect here with crocodile clips to an ohmmeter. Okay, multimeter acting as an ohmmeter. We're going to put this in the water. Okay, and we're going to increase the temperature of the water and take our resistance at each temperature. Simple as that. We're doing the same experiment with this. This is a thermistor. Now again, right, take out this. Okay, the thermistor is actually right down here in the bottom. Okay, in that white section there. Okay, and this is all just for protection again. So when you're doing this yourselves in September, okay, you'll be using these. Okay, I'll do a mock-up or a quick version of it in a minute. Right, so all you have is, in both cases, okay, so in the first case you have a coil. Okay, and the coil we just connect to an ohmmeter. Get used to the ohmmeters at this stage. Okay, now traditionally that would be put into glycerol, okay, which is liquid that doesn't conduct electricity. We don't do that anymore, the apparatus is so much better, but we always throw it in because it might give us an extra mark or two. Okay, and we put that into effectively a beaker of water with a hot plate. And warm that, so it's a hot plate. So the hot plate is there to heat the water. In the water, we put in a thermometer. We don't need to put it in here, beside the coil. Okay, we have a coil here. Okay, and that's it. Okay, so all we do is, we have a table, we have a temperature measured in degrees Celsius, and we have the resistance measured in ohms, or possibly kilo ohms, depending on the device. Okay, start at room temperature. Okay, so 10, 15, 20 degrees. Measure the temperature, measure the resistance, increase the temperature, and continue. Okay, always mixing the water before you take a temperature reading. Okay, and heat it away nice and slowly so that the temperature of the water and the temperature of the coil are at the same temperature. That's experiment E3. Experiment E4 is exactly the same, except you replace the coil with a thermistor. In both cases, you draw graphs of resistance against temperature, and having done, the coil should be familiar to you, as the lesson has gone on today. So basically, as the temperature goes up, you should have noticed that the resistance is going to go up. Okay, because remember, the atoms are going to start vibrating more. Okay, so it's going to be harder for the electrons to get through, or the charges to get through. So therefore, the resistance going. If it's harder, it's more resistance is greater. So you're going to have as the temperature goes up, the resistance is going to go up. Yeah. So you're going to have, and it is a linear relationship. Okay, so it will look like that. Okay, but it is not directly proportional. Okay, and that's important. It's not directly proportional. So it is not going through the origin. Thermistor, you will find it isn't linear, and as for a thermistor, you will find as the temperature goes up, the resistance actually goes down. So you're going to get something like that. All right, we'll run through it there now in a second.